Alright then, welcome back everyone. Let's solve this question, black and white strip. Now, this is one of those questions when changing the perspective helps. Sometimes like you will keep thinking about how to approach this solution and you won't be able to get it. Then it pays well to just change the perspective and look a question from different angle. Now, what I mean by this is you will see in a bit. To quickly summarize the question for you, you have a strip of checkered paper of length n, so that is n size paper. Each cell is either white or black, so it's a sort of a binary paper, right? Binary strip. What is the minimum number of cells that must be recolored from white to black in order to have a segment of k consecutive black cells on the strip, right? So the question is simple. We have a n length strip and each cell is either white or black. What we need to do is we need to color minimum number of cells from white to black such that we have a contiguous segment of k black cells. If there are k black cells available like consecutively, then your answer is 0. That's what they've written here. Input is simple, n, k, and the string, of course, n, k, and the string, right? So n, k, and the string is the input. And what we want to output is minimum number of cells that need to be repainted from white to black in order to have a segment of k consecutive black cells. I guess no one would have been any doubt in the question. All right, so how do you approach this question? What they have asked us is we want to recolor some whites to black, right? So I've taken a simple example here, a general one, not from the Codeforces one. And what we want to do is we want to recolor some whites to black, that to minimum number of whites I have to recolor to black such that I can get k consecutive blacks. Okay, so what should be your approach? So if you give it a thought, what you will realize is that thinking in the direction of which white to turn into black by just looking at this string will not make much sense. Okay, so like if you just look at the string and think about, okay, how am I gonna convert? Like if you think like this, what happens if I convert this white to black? Then what happens? What happens when I convert this white to black? Or you might think like, what happens if I convert this entire segment to black? What happens if I convert entire this segment to black? What can happen? So thinking in the direction may not make sense, but what we actually want, I'll write in here. What we actually want is I want k consecutive B's with least W's recolored. That's what I want. Okay. So you want k consecutive B's. That's fine. If you are not able to think what W's to recolor, can you think what are the possible k consecutive B's? Very important. Since you are not able to think well which W's to recolor, can you think which consecutive B's that you have to consider? In other words, what I'm trying to ask here is, can you find all the possible k length segments, right? Can you find all the possible k length segments, k consecutive, right? So k length segments, fine. Segments are consecutive anyway. K length segments. Turns out you can, right? So what are the all possible k length segments? So let's just take this is k is 5 here, right? So first possible k length segment will be this, right? 1, 2, 3, 4, 5. Yeah. So first possible k length segment would be this. What is the other possible k length segment? It would be this. What will be the other possible k length segment? It would be this. What will the other possible k length segment? It would be this, right? Next one will be 5 to 9, then it will be 6 to 10, so on, right? So this is how you can find all the possible k length segments, right? Okay, so that gives us a idea. Okay, so these are like how many possible k length segments are there. So if you just keep on going this, you will realize that total number of k length segments are actually n minus k plus 1. Now this is a simple observation. You can maybe trace it out here, but you will realize that total number of k length segments in an array of size n will be n minus k plus 1. Or in other words, the total number of consecutive, like total number of windows of size k, unique windows of size k, will be n minus k plus 1. Windows or segments, subarrays, everything is one and the same thing here. Fine. Okay. So what next? Okay, so if you observe here, there are only order of n, right? So there are only order of n possible segments, right? All the possible candidate segments we will. Why candidate? Because your all blacks can lie in any one of these segments, right? So after recoloring, your all blacks can any one of this n minus k plus 1 segments. So these are our order of n possible candidates, right? So what you can do is, now since you know that there are only order of n possible candidate segments, like after after you have recolored some whites to black, why not find a segment with least number of w's, right? So find the k length window or segment with least w's, right? If you can find a k length window with the least number of w's, this is the window that you will recolor, right? Like these are the whites in this window are the ones you are going to recolor to turn into black, right? Okay, I'll repeat myself again. Firstly, we only have order of n possible candidate segments, order of n possible segments, that is k length windows in which we can have all the blacks, right? So since I want to minimize the recoloring, I'll choose a segment, I'll choose a window with least number of w's, right? And whatever least number of w's are there, I'm going to recolor them, right? So if it's confusing to you, let's take an example here. Let's just take this example here. So here there will be 12 minus 5 plus 1. So 8 total segments. So let's just see, okay, how are you going to do it? So first segment that we have to consider is this 1, 2, 5, right? So there are 5 guys here. We have to look at all the possible 5 length windows, and whichever has the minimum number of whites in it, that's what we are going to recolor, right? So this automatically will become our answer. Pick a segment which is least number of w's. So how many w's are in this segment, by the way? There are 3. Okay, so I'll maybe maintain a min here. So min is 3. Okay, so right now we have to recolor 3 whites to get a segment of all blacks. Okay, what is the next segment? The next segment is 2 to 6. How many whites are there? Oh, there are 4. So I'm not going to update it because there's no point in recoloring whites in this segment. You are better off recoloring whites in this segment. Fine, let's move on to the next one. 3 to 7. How many whites are there here? There are again 4. So no point in recoloring all the whites in this segment. Let's move ahead. 4 to 8. How many whites are there? 3 whites. We can recolor the whites here, no problem. But our best answer is still 3, so it doesn't really matter. Let's consider this one then. 5 to 9. There are 3 whites again, no point here. And then let's consider this 6 to 10. There are 2 whites. That's interesting. So if I pick this segment and recolor all the whites in it, I'll only need to convert 2 whites. So yeah, our answer is updated to 2. Let's move on to the next one, 7 to 11. Oh, that's even better. I only need to recolor 1 white. So minimum is 1. Let's move on to the next segment then. It will be, I guess, the last one, 8 to 12. Yeah. So here again 1, so fine. So this is our answer, right? So what happened is we considered all the possible k length windows or segments or subarrays, if you will, and we figured out the one which is least number of w's, and that will be our answer, right? Okay, so how are you going to implement it? Now, brute force can be to go through all the possible n length segments and count the number of whites in it, but that will actually cause order of n into order of n. So like it will be order of n square solution. So that won't work. So that won't pass the constraints. So we need something better, and that's why you are in this video, right? So this is a good starting point when you should know about this concept of sliding window. So sliding window in the sense like the name is name itself says what it is. You're gonna first put 2 pointers here. Let's say a pointer I here and a pointer j here. These pointers will always represent the bounds of a window element, right? So initially I'll have a window like this. So first I'll calculate the answer for this. Once I've calculated the answer for it, I'll move the window 1 step ahead. So I'll move the index variable. Once I have figured out the answer for this window, that is how many whites to recolor, I'll move this bounds 1 step ahead. Once I have figured out the answer for this window, I'll move the bounds ahead, right? But what is happening here effectively is you are not calculating for each and every segment. I'll not run a internal for loop, right? That I'll show you how we can do it. But yeah, once we figure out a window, I'll just gonna shift the bounds. Okay, so that's the idea of sliding window. Here I'm sliding a window, right? So that's why. So what you need here is you need 2 variables here, I equals to 0 and j equals to 0. These are the bounds of the windows. What other thing do you need? You need a way to keep track of whites in a window, right? So I'll initialize the whites initially to 0. So I, j are the bounds of the windows. So stay with me for a while, for next 2 minutes. You'll get it what I'm trying to say. 2 variables which maintain the bound of the window. And I also need a variable to keep track of whites. And whenever I move the bound, I'm going to update the whites. Simple, right? So bounds of the window and count of w's in this window. And we need this, right? Because order of n into order of n solution is not going to work. So if somehow performing a constant time operation, I can update the whites while moving the bounds, my job is done. We have order of n solution. So let's just see. Okay, let's go step by step. First, of course, we'll go till we have considered all the guys, right? All the elements. So if you observe this window here, will go then here, and finally at the last. Okay, so this will be the last, right? So 8 and then 12. This is how it will go. Fine. So till j is at the end, we will consider, okay, till we have not crossed the bound. If s of j is w, if there is a white, I'm gonna update the count of whites. Fine. Okay. So what I'm trying to do is initially I and j were pointing to first guy only. Right. Initially both I and j were pointing to first guy only. If I encounter a white, I'm gonna increment the white count. If I encounter a white, so this first, like, until we have reached like we have found a window of size 5, we are not gonna do any processing, right? So any which way, if s of j is equals to white, I have to update the whites count. Fine. And if window size is less than k, then we don't need to do anything. So if j minus I plus 1, so what is j minus I plus 1? J minus I plus 1 will be the size of the window. If you observe here, 5 minus 1 plus 1 will be the size of this window. It will be 5. If j minus I plus 1 is less than k, we don't need to consider number of whites in this window, right? So you can just increment j, move to the next guy, and continue. Right? So don't consider the answer for this. But if you are here, you have a window, right? So once j has reached 5, you have a window, and this whites will hold how many whites are there in this current window, like from this 1 to 5, because we are updating the whites before doing anything, right? So now what you have is whites hold the number of w's in the current window. That's what they hold, right? So what you have to do is you'll have to, of course, create a variable here which holds the minimum number of bytes that will be recolored. So I'll do mini equals to n. Why n? Because in the worst case, what happens is entire string can be made of b's, right? So in that case, we'll have to convert the entire string. So this is the worst case. That's why mini equals to n. Or anyway, you can set it into max, but fine. Okay. So mini holds the minimum number of bytes, right? So mini will be what? Minimum of whites and mini. Simple. And then we have to slide the window. Slide the window means j plus plus. But let's say, for example, here we have slide the window, right? So we have slide the window. Now this white will be added in the next iteration. Fine. But this is good. But now, okay, this is fine. This why, like, what this one new white will be added in the next iteration. But now when you slide the window here, this white needs to be removed, right? So this white is gone. So what you need to check here is, like, ideally you would also want to do I plus plus, but first you need to check if the left bound was w, then you have to decrement the white, right? Number of whites in the window have reduced. Fine. So yeah, that's that, and that's about the code. Actually, I'll summarize it in a bit, but yeah, and in the end you will have to print mini. So it is pretty simple. What we did is we went through all the k consecutive, like we went through all the possible k length windows, and we find out a window with the least number of w's. That's what we're doing. And to do that, we are maintaining two variables, left and right bound of the window. Okay. So first things first, we'll update the number of whites as soon as we enter, and then until the window size has not become k, we are gonna keep incrementing. We are gonna first reach the size of a window to be k. And then whenever you have a window size of k, first I'm going to update the number of whites in it, and then I'm going to slide the window. Update the number of whites, update the answer, not the whites. Update the answer, and then I'm going to slide the window. Right? So yeah, that's about this. Let me just quickly run it. Well, there is a stupid mistake. This should be double equals to. Now I'll run it. Yeah, this seems to be working. I'll quickly submit it. It works. Thank you for watching. I'll see you in the next one.